Hello. If you're watching this, you missed day one of our week two computer science principles class. Let's get to it. So this is the day where we continue traversals and we really get into the nitty-gritty of how to use them, and you guys practice those ideas so that you can do it yourselves. Last class, we reviewed some really difficult concepts that involved using a sort, which we called selection sort. We're going to come back to that later in the year, so if you didn't quite grasp all the fine points of that, that's okay for now. However, everything we're doing today and onwards really with traversals, you should be able to do yourself. So these things I'm about to show you, I am expecting you to be able to do. Today we did a short warm-up, then we talked about databases, which the warm-up was really related to. Then we did traversals practice, and we didn't quite get to traversals make. We will do that next time, which remember is going to be Wednesday because of the strange schedule, the 10th. Now, coincidentally, the traversals practice, our first assignment, is going to be due tomorrow, Wednesday the 10th, at midnight. It involves you completing all the bubbles in Unit 5, Lesson 11, bubbles 2 through 9. You need to do all of them, 1 point each, and that's going to be a total of 8 practice and participation points. Our second assignment, Traversals Make, we will start tomorrow, is going to be due Wednesday the 17th, and is worth 21 all assessment points, so a lot more. Let's get to it. So the first thing to do is to take a look at code.org and to investigate what there's going on with these traversals, in particular intro to datasets, which is bubble number 3 of lesson 10. As an aside, if you haven't yet joined the correct code.org section, then you need to make sure you do that. If you don't know how to do that or what I'm talking about, please send me an email and I'll be happy to assist you. But if you don't do that, I cannot give you a grade for anything you do on here, and you'll end up with a bunch of zeros, which would be pretty tragic. All right, so this bubble here, what are we doing? This bubble is all about figuring out how data sets work. So we took some time for you guys to just click around and explore it, but I'm going to show you here explicitly. If you click Data up here in the top left, it allows you to access what's basically an Excel spreadsheet. There are several already uploaded here for you, and you can make your own if you would like. Let's go ahead and open up this one. This one is the Women's March attendance by U.S. city. So you can find the city, the state, the estimates, the guests, the sources, and so on and so forth. So this is a full-fledged table. We've got all kinds of entries and can be quite long. I think this one's got upwards of 100 entries or so. So lots of options, or maybe even more, maybe 1,000. Wow, 500 entries. So there's a lot of information to be gained here. How do we actually work with this information? Well, in your code, you can say get column, and then what column you would like to get, the name of the table, and then followed by the name of the column. When you do that, it'll essentially return what is a list. And you can store that list into a list variable if you would prefer. And you might say, Mr. M, why do we even want to bother with this? Why don't we store everything as lists to begin with? What's the point of this data set? Well, the point of the data set is this is our first instance of persistent memory. If you restart any of your programs you've written so far, you're not getting any of that information saved. It's going to start all over. So if you want to save, let's say, a high score, you cannot do that with the tools we currently have. However, you can do that using data sets. Currently, we can only read data sets, but later on we will introduce the ability to write to them as well, and that would be how you want to store information like a high score that you want to persist over multiple individuals or times your program is run. So very powerful and useful tool. Another thing to look at would be this bubble here, bubble 4. This shows a much more in-depth use of a data set. Here we read several columns for dog height, names, and images. And then we use that information in a list traversal. Here's the list traversal, where we iterate through the list and we look for the dog height. But as we do, we also reference the names and the images using the same index. Why does this work? Well, if you think about the data that we're looking at, remember that each row of the table matches the information from a specific dog breed. So what that means is if I look up the name of the dog at index 0 and also the lifespan at index 0, it will be the lifespan for that same dog. Very, very nice and useful because this way we can iterate through the dog heights and then get the relevant names and images by using the same index. So that's what you guys need to take away from this, is you can get multiple columns and you can iterate through all of them at the same time. All right, now what about our assignment? So let's go back and take a look at that. By Wednesday the 10th at midnight, you guys need to complete the following. Lesson 11, bubbles 2 through 9. In particular, I'm going to show you bubbles 2 and 7, in case you have trouble with those. 2 just because it's the very first bubble, so you might want some guidance on just how to get started here. And 7 because it's a tricky bubble, and tricky bubbles are tricky. So let's go ahead and just show you how to do this first one. So this first one instructs you that we're going to traverse through a list of fruits, and we're going to display their names, and it does so. Here's the list of fruits. We're going to go through each one and display it. We'd like to do the same thing to a list of vegetables. Well, let's write this code together. Whenever you want to traverse, you have to start with a for loop. I'm going to use the same value I that was used up here, just because, remember, I ceases to exist as soon as you hit this closing bracket. You certainly can use a different variable name if you prefer, but I just like I is going to be less than, well, in this case, vegetables dot length, since that's what we are going to be traversing through, the vegetables array. I++ will increment the I by 1 each time we go through the loop. And then if we want to print out each vegetable, you have two options. You can either make a vegetable variable. Be very careful not to name it vegetables, as that will override your entire array and cause all kinds of issues. Or the alternative, which I'll show here, is you can just reference the array directly. You don't need to have a separate variable. You can say vegetables at I is what I would like to display, please. And this works just fine, so long as we're not making some kind of change here that we would want to avoid making to the entire array. Also, spelling is important. So this might be a more useful way to do this if instead of printing out the fruit, we were going to do something to it if we didn't want the original array to be affected. Like, let's say we were going to modify that value by changing the number of letters or rearranging them in some way. Then this would make a lot more sense. But for this purpose, either solution works just fine. If we run it, you'll see we display the vegetables as well as the fruit. Now let's take a look at bubble number 7. Now remember, you do have to do all the rest of these. I will be checking them. Please make sure you don't forget to do them all. But I wanted to just highlight this particular one because this one involves data sets, which is the new concept we talked about today. So how does this one work? We have a list of states, and the table that we're given, if we take a look at it, has all kinds of information. The code names, the nicknames, website, mission year, population, all kinds of crazy things you can find out. What we're going to do is we already have code that looks for all the states that became states after 1900. We are going to look for all the states that have population of less than 1 million. How do we do that? The first thing I want to point out is this is not a good naming convention. You should avoid having numbers in your variable names. It's not a good idea. So I personally am going to rename this to 19. You don't have to do that, but this is not a good naming convention. So I'm very cross with code.org for including it. All right, now that I've fixed that, let's go ahead and take a look at how this is done. We're going to iterate through all the states, the list of states. We're going to store the name of the state and the year that it joined the union. And then if the year happens to be larger than 1900, we're going to append that state to our output list, which we called since 19 list. All right, sounds good. Let's do the same thing, but now with population. We have an output that we're going to store to called small population list. We have a traversal that's going to go through the state list, It's going to store each state inside state and the population inside population. So all we have to do is make a check. Whenever you check for something, we use if. We want to see if the population is less than 1 million. If it is, then we need to go ahead and add it to our list. So what do we actually add? We want to do append item. We want to add to the small population list, and we want to add the state. If you do that and run it, you should see the correct answer, which should have 6 states. Now, one really common issue that I would like to point out is sometimes you might be tempted to do something like this. You might want to say, instead of append item, this is a very tempting solution, but it is incorrect. This does not work. Why doesn't this work? Well, if I try to run it, you'll see that this gives me a huge error. And it gives me an error here on line 42, and you might say, well, line 42, that's just a printout. What's wrong with that? The issue is, you're storing things into this list, but you're leaving gaps. Gaps are deadly. You cannot do that to a list. It ceases to be a cohesive array if you do that. So how does this work? We have a bunch of lists, maybe 50 of that, or states rather, 50 of them. And each time we iterate through one, we choose whether to add it or not. That means that not all 50 are added, which means that maybe slot 4, 5, and 6, there is no state that fits. And then the 7th slot, we'll put one in. Well, the issue with that is if we try to print out this list, which this does, it doesn't know what to do for the blank spaces. That's why it says type error, E is undefined. It doesn't know what this blank space is. It's very confused. So do not do this. This is not a very safe operation to attempt. Sometimes it makes sense to do that, but you have to be very, very careful. Append item is always safe. That's why we use it. Or insert item. Both are good, but please be careful. With direct assignment, you can get into a lot of trouble, as was just shown. If you have any questions or any of these other bubbles or concerns or are worried about finishing on time, please make sure you send me an email and I'd be happy to work with you. Otherwise, have a fantastic rest of your day and I will see you later.